When we want to multiply vectors, there are two different ways we can do it. We can do something called a scalar product, which is also known as the dot product. It's a way to multiply two vectors together and yield a scalar. We write this as A vector dot B vector, and this is equal to A times B times cosine of phi, where phi is the angle between the two vectors. So it looks something like this. I have a vector A, and I have a vector B. And there's an angle separating them that's equal to phi. What I can do is I can look at this. I can look at this and I can see what actually is happening here if I break this B vector into its X and Y components. So I start at the origin, I draw my way over until I'm right underneath the tip here, and then I stop, and that gives me some value bx. And then I can draw the value going up. So I'm drawing that right triangle. We need to be really good at these right triangles. I'm not joking on that. We want to go crazy drawing triangles. Okay, so if I look at this triangle, I can see some things. I can see some trig functions. I can see the sine of the angle. So sine of theta, or sine of this angle phi, is equal to the opposite side, this by over b. I can see that the cosine of this angle, cosine of phi, is equal to bx over b. And I can actually solve this, right? I can solve this for bx, and I'll see bx is equal to b times cosine of phi. And that looks familiar, right? This b cosine phi is right up here in the definition of the dot product, b cosine of phi. So that kind of gives us a clue as to what we're doing. The bx we see here is going in the same direction as the a vector. So the dot product selects out and figures out how much of one vector is going in the same direction as another vector and multiplies them together. This has a name, has a fancier name. We call this an orthogonal projection. So what does this look like in a problem? How do we actually do a dot product? Okay, let's say we have a vector A. Let's say that's equal to 5. And we have a vector B. Let's say B is equal to 10. And there's an angle between the two that's equal to 30. If I want to do this dot product, I can do A dot B equals A times B times the cosine of phi, the angle between the two. A is equal to 5. B is equal to 10 times the cosine of this angle. This angle is 30. Plug this in, and you'll get an answer of 7.71. And because this is a dot product, also known as the scalar product, this is your answer. It's just a number. The dot product is a number. Dot product, or a scalar product, is a scalar, just a number. Let's do one other example. Let's say I have a vector A. Let's say A is going up. And let's say A is still equal to 5. And I have another vector B. B, let's say that's still equal to 10. Let's say the angle between the two of them is 90 degrees. A dot B equals 5 times 10 times the cosine of 90. Plug this into your calculator, and you would get a big fat 0. Okay. So what this tells us is something kind of cool and kind of useful. Dot product is 0 if your vectors are perpendicular. So that is the dot product. That's one way we can multiply two vectors together. We also have something called the cross product. So the cross product is another way. Cross product, also known as the vector product. It's how you multiply two vectors together and get out another vector. So if I want to know the magnitude, again, remember these two bars that I draw, that represents magnitude. The magnitude of A cross B is equal to A times B times the sign between the two. So it's easy to find the magnitude, do it just the exact same way. Easy peasy. How do we find the direction? Because the cross product gives a vector. Direction from the cross product. And here's a little shortcut that will show you. So it's going to draw a little circle. I'm going to have the I hat, I'm going to have J hat, and I'm going to have K hat. And on the outside, I'm going to have positives and arrows going clockwise. On the inside, I'm going to have arrows going counterclockwise. And I'm going to have negatives with all of those inside arrows. And what does this mean, though? So let's say I want to know I hat cross J hat. Well, I know the magnitude is going to be 1 because cross products are equal to 1. And I can look at this little diagram that I've drawn. I start with the first vector. First vector is I hat. Okay. And I want to cross it into J hat. So I start at I go to J, and I can see if I want to go from I to J, I follow this arrow. Right? And then from J, if I keep following my arrow, I'm going to end up at K. So my final direction is going to be the K hat direction. Let's see another one, how that works. So if I want to know K hat cross I hat, I'm going to start at the first vector, K hat, and I'm going to go follow this little arrow. If I follow that arrow, I get to I hat, which is the second vector that I want. And if I keep following this direction, the last vector I end up with is the J hat. Okay. So in the first one, I'm going clockwise. Second one, I'm going clockwise. Let's look at another example. Hopefully, after these next two examples, this will make sense. K hat cross J hat. What does that give us? So I go to my K hat. So here's my K. If I follow this outer arrow, the only way I can go, the only letter I can go to next, following this arrow going clockwise, is I hat. But I hat isn't the second vector I want. I want J hat. So if I look at this K and I follow this inner arrow, go the opposite direction, I get to my J hat. And then I keep following this arrow around, and I get to I hat. So K hat cross J hat is going to be I hat, but I went counterclockwise. I use this inner circle. So the inner circle means that that's going to be a negative. Let's do one more example. Let's do one last one. Let's do I hat cross K hat. So I start at the I. There's my I hat. If I follow the outer circle, go clockwise, that would lead me to J hat. I don't want to be led to J hat. I want to be led to K hat. So I have to follow the inner circle, which goes counterclockwise. I'm going counterclockwise. That gets me to K hat next. And then I keep following that, and that gets me to the final answer of J hat. So this is J hat. And since I went counterclockwise here, that's going to be a negative. Okay. So what I'm going to do now is I'm going to offer an extra credit opportunity. So for extra credit, what I want you to do, this will be worth one extra credit point. I want you to upload this along with your homework by the early homework due date. Okay. I want you to make a video, some kind of screencast, some kind of thing where you're showing and describing all the algebra necessary to find the general cross product. Generalized cross product. of A cross B equals C. And I want this in expanded vector notation. So these are two vectors giving me a third vector, and A is going to be equal to AX, some magnitude in the X direction in the I hat, plus AY in the J hat, plus AZ in the K hat. And same thing for B vector. B vector is going to be BX in the I hat, plus BY in the J hat, plus BZ in the K hat. And you want expanded generalized vector notation. And I'll give you a hint for this extra credit. Equations 2.36 through 2.39 will be useful. So there's an extra credit opportunity to upload along with your homework by the early due date.